Hey everyone, and welcome. Today, we're going to jump right into one of SQL Server's most critical and honestly most misunderstood databases. We are going to demystify TempDB and give you the ultimate setup guide, and we're going to do it all in about 5 minutes. So let's get right to it and fix one of the most common performance killers in SQL Server. So let me ask you something. When your SQL Server suddenly starts crawling for no good reason, and you're pulling your hair out trying to find the culprit, what do you think is the #1 cause of those mystery slowdowns? The answer might surprise you.
Yep, more often than not, it's TempDB. This one single system database is so often the bottleneck behind those super frustrating, hard-to-pinpoint performance issues. It's a shared resource, and when it's not configured right, it can literally bring a powerhouse server to its knees.
Okay, so to fix this thing, we first got to understand what it does. Let's pop the hood for a second and see why it's pretty much the busiest database on your entire server.
You know, I absolutely love this analogy from SQL Server expert Brent Ozar. He calls TempDB the public toilet of your SQL instance. And it's perfect. Think about it. Every single process, every query, every user, they all have to line up to use this one shared spot for all their temporary work. It's got crazy high traffic, it's essential, and you can bet if that thing gets clogged, everyone has a problem.
And just look at this list. The crazy thing is it covers pretty much everything you do in SQL Server. We're not just talking about the temp tables you create yourself. It's sorting, it's index maintenance, it's snapshot isolation. The entire engine uses TempDB as its universal scratchpad. And that's exactly why a problem in TempDB becomes everyone's problem real fast. Okay, enough theory. We get it. It's a busy place. So let's cut right to the chase. I'm not going to make you wait for the good stuff. Here it is, the cheat sheet for a perfectly configured TempDB. This right here is the golden ticket. Seriously, screenshot this. Put TempDB on its own dedicated fast drive. Local SSD is absolutely king here. Create 8 data files and make sure they're all the exact same size, 1 log file. And then pre-size all 9 of those files to completely fill up that drive. No more surprises with auto growth, just solid, predictable performance.
But why 8 files? What's so special about that number? Why does this recipe work so darn well? Well, it all comes down to fixing this one really specific traffic jam that happens inside SQL Server.
So the technical term for this problem is allocation contention. But forget the jargon. Just think of a massive traffic jam. When tons of queries all try to create temporary objects at the exact same time, they all have to get in a single file line to update these internal address book pages that keep track of free space. And this is key. This isn't about how fast your disks are. This is a bottleneck happening right inside SQL Server's memory. And this slide just lays it out perfectly. With just one data file, you've got a one-lane road, and all your queries are stuck in traffic just waiting. But when you add multiple data files, what you're really doing is building a multi-lane superhighway. Each file gets its own set of those address book pages, which spreads the workload out and just lets the traffic fly.
All right, so the theory makes sense, right? But how do we actually do this on a real live server? Let's walk through the exact steps.
So that magic number, what is it? For pretty much any modern server you're going to touch, it's 8. Don't overthink it, just start with 8 data files all the same size. Just doing that one thing solves this allocation contention mess for the vast majority of systems right out of the box.
Okay, I can hear you now. You're thinking, hold on. My server is a small VM. It only has 4 cores. It's the #1 question I get. And don't worry, there's a super simple rule for it.
It's this simple. If you have 8 logical processors or less, just match the number of data files to the number of processors. 4 cores, 4 files. 6 cores, 6 files. See? Super straightforward.
Okay, listen up, because this part is absolutely critical. Your files have to be the exact same size. See, SQL Server uses something called a proportional fill algorithm, which is a fancy way of saying it sends more work to the file that has more free space. So if one file is bigger, it gets hammered with all the traffic, and you've just gone and created the exact same bottleneck you were trying to eliminate. So yeah, equal sizing, it's totally non-negotiable. So what if you need to fix a server that's already running? It's actually pretty easy. First, just see how big your TempDB data file is right now. Then, divide that size by your target number of files. Let's say 8. Shrink that original file down to the new size, and then just add 7 more files of that exact same size. Then you'll need a quick restart of the SQL service, and that makes sure the workload is spread evenly from the get-go.
All right, let's move on and bust some mess, because there's a lot of old advice floating around out there and things have really changed, especially since SQL Server 2016 came out.
Man, this slide is so important. If you learned this stuff a while back, you were probably told you needed trace flags 1117 and 1118. But here's the great news. Since SQL Server 2016, all that good stuff is built right in. You can just forget about those trace flags for TempDB. The modern way is simple. Presize your files and don't rely on autogrow.
And just a quick word on storage. Local SSDs. Use them. Always. They're crazy fast, and they keep TempDB's activities separate. Having a dedicated drive is a lifesaver because it means one bad query that fills up TempDB won't take down your entire server. And just to be clear, all of this 100% applies to your VMs too. No exceptions.
So you did it. You followed the recipe. Your TempDB is on a screaming fast drive with 8 perfectly sized files. Your job is done, right?
Well, not quite. See, the setup is just step one. Now comes the important part, monitoring. Here's the thing. A properly configured TempDB should almost never have to grow. If it does, that's your alarm bell. It's telling you a query is going rogue. You can use these dynamic management views to keep an eye on things and hunt down those space-hungry queries. Because look, having a great configuration is awesome, but really understanding and monitoring your TempDB, now that's what's going to guarantee amazing performance for the long haul.